Welcome back, everyone. Today we've got a really fascinating explainer of the source material lined up for you. We are going to dive headfirst into the intense, highly skilled world of welding. Now, just to ground our focus right off the bat, a brief note about welding positions. In this field, the position simply refers to the orientation of the weld joint and how the operator actually has to move their electrode to complete that weld. Sounds simple enough, right? But as we're about to see, the ultimate opponent out there isn't actually the metal itself. Nope, it's the constant, totally unforgiving pull of gravity.
Here is our agenda, essentially our certification map for today's climb. Number 1, gravity, the welder's frenemy. 2, fillets, grooves, and joints. 3, plate positions from 1G to 4G. 4, pipe positions 5G and 6G. 5, decoding those global standards. And finally, 6, mastering the weld. Let's get right into it.
Section 1, gravity, the welder's frenemy. So is gravity your best friend or your absolute worst enemy? Honestly, it's kind of both. Think about it. A welder's main job is to create a molten pool of liquid metal, the weld pedal, and carefully manipulate it to fuse two pieces of solid metal together. When you're just working flat on a table, gravity's your absolute best friend. It keeps that liquid puddle calm, predictable, and draws it evenly right into the joint. But the very second you move off that horizontal plane, oh man, gravity turns into this dripping, uncontrollable nightmare. It actively tries to pull your molten metals straight down onto the floor, or worse, right onto you. It totally dictates the technique, the heat parameters, and the sheer physical stamina you need to get the job done.
Moving on to Section 2, fillets, grooves, and joints.
Before we really start our climb today, we have to understand our structural canvas. You're going to see the letters F and G a lot in industry codes, representing the two main types of welds. A fillet weld, marked with an F, is placed right beside the junction of the workpieces. Think of joining two pieces of metal at a 90-degree angle. That fillet weld sits right there in the corner. On the flip side, a groove weld, marked with a G, is formed right in the physical gap between two workpieces, usually extending all the way through the thickness of the metal.
And we apply these fillets and grooves across 5 foundational joint shapes. You've got the butt joint, where two edges meet head-on, the lap joint, where pieces literally overlap, the T-joint, which, you guessed it, forms a T-shape, the corner joint, where pieces meet at their ends, and the edge joint, where parallel edges are joined together. Definitely keep these shapes in mind, because how we tackle them changes drastically depending on how they are oriented in space.
All right, Section 3, plate positions, 1G to 4G.
We kick things off at base camp, 1G, the flat position. The metal plate lies perfectly flat on the table, and the welder simply moves the electrode horizontally right across the top. This is by far the easiest and most common position because, like we talked about, gravity's acting as your trusty assistant. It just draws that molten filler metal downward evenly into the joint. Because of that, you can run the machine hotter, move faster, and lay down metal with some seriously incredible efficiency.
But out in the real world, you can't always just plop your work on a nice, flat table. Moving up to 2G, the horizontal position. The metal plate is standing completely vertically, but the weld joint runs horizontally across its face. Suddenly, gravity is pulling your liquid puddle down the side of that vertical plate. So the operator has to constantly adjust their torch angle, usually pointing it slightly upward, and favor the top edge just to prevent the bead from sagging down and causing a nasty defect known as cold lap.
And this right here brilliantly illustrates why the joint type matters so much. A 2F horizontal fillet weld is actually quite a bit easier than a 2G horizontal groove weld. Why? Well, with a 2F lap or T-joint, the bottom piece of metal creates a literal physical shelf that catches the sagging molten metal for you. A 2G groove weld doesn't have that handy little shelf. It's just an open gap, which makes puddle control infinitely more difficult.
Now things get seriously tricky at level 3G, the vertical position. Here, you're welding straight up or straight down a vertical wall. To stop the molten metal from just pouring right out of the joint, you actually have to change your machine parameters. Specifically, you drop your wire feed speed and voltage so you're running cooler. And you can't just drag straight up either. Welders have to use super precise puddle manipulation, like a zigzag motion or weaving stacked triangles, to literally wash the puddle over to the cooler edges of the joint, locking it in place while it solidifies. Then we hit the ceiling, literally, the 4G overhead position. This is widely considered the ultimate test of patience for plate welders. You are welding on the underside of a horizontal plate. Gravity is now a direct, relentless threat trying to pull tiny drops of molten metal straight down onto you. Welders are forced to use tight, small stringer beads to keep the puddles small and manageable. And obviously, they have to be completely decked out in heavy protective gear, making sure that jacket is fully buttoned up. Because fighting a 4G weld basically means fighting a continuous, unforgiving shower of hot sparks trying to find their way straight into your boots. Which brings us to Section 4, Pipe Positions, 5G and 6G.
So imagine a massive pipeline out in the field. You definitely can't just pick it up and turn it around, right? In the 5G position, the pipe is horizontal but completely fixed in place. To weld all the way around that seam, the welder has to seamlessly transition through flat, vertical, and overhead positions, all in a single continuous pass. You have to adapt your heat, your travel speed, and your torch angle on the fly because gravity's impact is constantly shifting as you move around the curve of that cylinder.
And then, just to make things as brutal as possible, we introduce a severe 45-degree angle. This is the 6G inclined fixed position. The pipe is locked in at a 45-degree slope, and the welder has to navigate the entire circumference like that.
This is known as the Everest of welding tests. 6G is the absolute ultimate proxy for a welder's overall competence. You are fighting insanely awkward angles, shifting gravity, and intense physical fatigue. Passing a 6G certification, which, by the way, almost always includes a strict X-ray inspection to check the inside of the weld for tiny hidden flaws, is the ultimate credential. It's literally the key to unlocking those high-paying, ultra-demanding jobs in structural construction, oil and gas, and major pipeline installations.
Now let's tackle Section 5, Decoding Global Welding Standards. It's kind of an alphabet soup out there. In the Americas, the standards set by the AWS and ASME use the numeric system we just learned, 1G for flat, 2G for horizontal, all the way up to 6G. But internationally, under the ISO standard, they actually use a letter-based system. So an American 1G flat weld is known globally as a PA position. A horizontal fillet is PB. And that grueling overhead 4G weld we talked about, over in the ISO system, that's designated as PE. Understanding both of these codes is absolutely essential if you're interpreting blueprints or trying to secure contracts worldwide. Finally, Section 6, Mastering the Weld.
So what's the big takeaway here? Why does mastering these positions matter so much? It comes down to three crucial things. First up, structural integrity. Welds performed out of position, like vertical or overhead, carry a vastly higher risk of defects, like undercutting, trapped slag, or incomplete fusion. And a weak joint can literally compromise a massive skyscraper or a high-pressure pipeline. Second, production efficiency. Fighting an awkward position is exhausting for the operator and really slows production down. And third, operator safety. Proper training for 3G and 4G ensures welders know exactly how to handle the heat, the falling sparks, and those awkward angles safely without getting hurt.
But you know what? The industry actually has an ultimate cheat code to avoid out-of-position welding whenever humanly possible. It's called the welding positioner. This is heavy industrial equipment that physically clamps onto massive metal parts and rotates or tilts them for the operator. Why? So the welder can just stand there comfortably and weld in the easy, safe 1G flat position all day long. It heavily reduces fatigue, speeds up production timelines, and guarantees higher quality gravity-assisted beads every single time.
Which brings us to our final thought for this explainer of the source material. With incredibly advanced robotic arms and massive positioners bringing almost every factory weld right back down to that easy 1G flat position, what happens to the manual welder? Will the incredibly grueling journey to master the 6G Everest slowly fade away into a lost art? Or is it going to remain the absolute, irreplaceable badge of honor for field workers and pipeline specialists everywhere? It is a truly fascinating intersection of raw human skill and modern industrial automation. Thanks so much for joining me on this climb today, and I really hope this gave you a solid grasp of exactly what it takes to master the metal.